I work on F# and other .NET stuff at Microsoft, more specifically kind of a mix between tooling and compilers that we have there. And I'm going to talk about Visual Studio, kind of. Not like actually exactly Visual Studio, but I want to show you that image so you can get a sense for what I talk about and kind of how it all fits together. It's F# and Visual Studio has a lot of different stuff. It's got project integration support, debugging, auto-completion. It's got tooltips, pretty printing, all that sorts of stuff. And so it's kind of a question of where does that all come from? Well, the general approach that we take is it all comes from the compiler, but not a compiler in the traditional sense. So typically you write compilers, like certainly in college, as like a little black box. It takes a string, or I don't know, maybe something else, and it turns it into a tree. It traverses the tree, it turns that into a tree, it traverses that tree, turns it into another tree. Eventually you end up with like a final tree, and then you usually turn that into some artifact that is either interpreted or executed directly. And that's certainly useful because, hooray, you can compile a program and you can run that program, but that's not really something that you can tool, because every single time you want to get useful information in an editor, you have to recompile things and see the result, and maybe have some additional tool that observes that result and tries to display it in some way. And so we like to think of the F# compiler as actually an API, a server process, and a database. So the database is all the symbols, the trees, diagnostics, that's sort of that all stuff is computed and stored. Sometimes in a cache, it could be serialized somewhere else. It kind of depends on whatever you like. And that is hosted in a server process, which is where the actual compiler lives. And that thing accepts a bunch of requests over an API surface area. And those requests can be like navigation. You say, I want to complete at this point in time. I want to analyze a document, perhaps get a code fix for that. I would like to see a tooltip, so I could see some stuff inside that tooltip and maybe get something useful out of it. There's a whole lot more than just that. I just showed 4 because those are some of the more general ones that people will use. And to be able to accomplish that, the compiler needs to have good error tolerance. Kind of bar none, that's like the most important one, because users' code is always broken. Like certainly from the perspective of when you're writing tools, it's very rare that a user code is actually correct, because people are just figuring stuff out there. Like their types are broken, their expressions are incomplete, they're moving stuff around, they're changing the structure of their code, they're changing the semantics of their code, they're doing it all the time. And they want to have the tooling react to that very quickly, because nobody likes it when you sort of know what something should be, but you're waiting for the tool to update with information, and you just kind of sit there twiddling your thumbs and getting very mad at the tooling vendor, perhaps Microsoft. And in addition to that, it's also nice to have a whole bunch of different features, right? Because programmers are a diverse bunch who have a diverse set of things that they like to do, and some people may like one feature and hate another, and vice versa. Some people may want to have 0 features at all. Some people may want to have every single feature on the face of the planet and little bells and whistles and little spinny thingies everywhere, kind of showing them that things are happening on their machine. And you need to be able to sort of understand that all of this is something that people will want, and ultimately, at the heart of all of this is a compiler for programming language tooling. And you have to understand that when you go into figuring out what you're going to do. So when we think about compiler APIs, we distinguish them between structure and semantics. So the structure of a program is generated via parsing, so we can see the shape of what's going on. And type checking or binding, depending on the nomenclature of your language, provides semantics, which is fairly straightforward. And so you want to have APIs to be able to parse and type check in various contexts. Like it may be a single file just sort of sitting in space somewhere, or it could be a file that is grouped with other files in a project, or that project may be a part of other projects, and you sort of want to understand the context in which everything is in. And then you want to have APIs, this is typically where the features come in, that operate on that data so that you could use it, hopefully for something useful. So as kind of a very brief round robin about how those sorts of things fit together, colorizing syntax, and I mean just like basic colorization, like distinguishing keywords from values or something like that, or keywords from literals. That's sort of where this sort of stuff comes in when you just parse. You can get context for auto-completion, actually. So if you want to get a very good list of stuff that you could try out, And you want to have context for, okay, what should that list have in there so it can be trimmed instead of just this giant global list of every possible thing ever that's typically given from the parse tree. You can provide code outlining and code folding, so you could look at the scope of something and maybe collapse it in an editor or open it back up if you like. Breakpoint resolution, which I'll talk about later. Structural navigation, being able to navigate like, oh, I have this module. Inside of this module, there are these functions. I would like to go to this specific function inside of this module, inside of this file. Auto indentation and pretty printing. So once you have a bunch of stuff, you can go and pretty print it, say in a tooltip, which can be kind of helpful to people. And diagnostics on syntax, which are kind of one half of the diagnostics piece. And then, of course, semantics kind of supplies the rest. Auto-completion, the thing that I mentioned before, that's what actually gives you the things to complete because it needs to know based off of what all the types are. You can get type information in the tooltip, semantic colorization, so you can distinguish between, say, for example, in F#, there's mutable values and non-mutable values, or non-mutable meaning the default, and so you want to sort of know if something is explicitly being made mutable. You could color that in a very ugly color so that people know to avoid that sort of thing in the future. We do this. You can do semantic navigation constructs, so being able to find references, being able to go to the definition of something, being able to analyze a document and provide code fixes based off of what we found. And diagnostics on semantics, being able to see, hey, do these types fit together? It's kind of also a useful thing. Probably should have been at the top rather than the bottom. To give you an example of how some of this can kind of work, breakpoint resolution is something that happens a lot in Visual Studio and certainly other editors, which is when people want to debug. And typically they're going to click in the gutter over there. So if you see by line 327, there's a nice little red dot. That's a breakpoint, and that's your indication in the editor that when we try to execute this, we're going to pause execution there and hopefully have enough information for you to diagnose what's going on and fix your problem. I just randomly snapshotted this out of the F# source somewhere in the compiler. You forget the file. And so additionally, we want to highlight somewhere in the document where that breakpoint corresponds to. And obviously, we're not going to display something if we can't resolve a breakpoint. So we're given a document, and we're given a line where they clicked, and that's it. So the question of, okay, how do we display this? Well, you parse it, and then you just traverse it. It's real easy. So once you have the parse tree, you want to traverse it, and you traverse it based off of the structure of syntax. So in the case of F# syntax, there's this big, huge union that has all these different cases, and each case represents a distinct syntactical construct in F#. And so, for example, there's if expressions, which you saw earlier right there. Well, an if expression, part of it includes a keyword, a predicate, and another keyword. So for the purposes of debugging, you don't want to process the keyword parts really, because that doesn't make sense to pause execution on a keyword, right? But you might want to pause execution on the predicate part. So for every single syntactical construct, there's sort of a custom rule for, okay, what part of the syntax do we think is debuggable or not? And so that's sort of like a first check that's applied at every node that we're sort of looking at. Then after that, we want to check to see if it's within the range of the line that somebody actually set the breakpoint on. And if it's not, obviously that's not something that we want to resolve a breakpoint to, because that's not where they clicked. And then lastly, we want to check to see if there's a thing called a sequence point, which is metadata that the compiler maintains about your syntax. And so this sequence point stuff, I think this is probably somewhat common across debuggers, but sequence point is the particular name used by Microsoft's debuggers. It's basically just line and column information about syntax, and it informs the debugger, hey, this is the actual spot. But we need to display something visually and not just have somebody click somewhere, get no visual feedback, and then they hit debug and then it actually breaks. We want to inform them, hey, this is where you clicked, it's going to break at this point. So if there's a sequence point at that position, basically, then we say, okay, we have a debuggable node that we think is a good candidate, so we're going to yield that back. And I say candidate because you can have multiple expressions on the same line. And so although typically you're just going to want to have the first thing be the one that you debug on, because that's typically how people, at least in with languages like F# and I imagine most other languages, they typically read the code from left to right. And so they're usually, when they're clicking somewhere far on the left, they're assuming it's going to be the leftmost expression that gets broken on. You can actually place your cursor somewhere in the editor and hit a different keyword, and it'll try to break on that specific expression. But that's sort of the only nuance there. So once we have the set of candidates, we reduce it down to 1. We say, cool, we found it. Okay, so hooray, that's how you do tooling. Actually, no, unfortunately, I wish everything was just as simple as getting a parse tree, traversing it, and calling it a day with a little node that you gave back to someone. So once you get past sort of the fundamentals of just traversing trees and giving information back to a caller, you end up really spending your time in the constraints of a programming language, because no language is perfect, unfortunately. And they all have little quirks that, especially if you're diving deep into programming language tooling, you are guaranteed to find and you are going to struggle with. So one example in F# is expressions and debuggability, which I just talked about. These two have a bit of an impedance mismatch, because I can write a beautiful fixed point F# that has 0 explicit values anywhere. And if I want to say, hey, I want to now debug this thing, well, it's kind of weird, because there's no explicit value being passed around. Like, I mean, yes, at the caller it gets passed in, but then we're in this weird situation where I'm like, oh, I want to debug this thing, but I now need to be looking somewhere else. And so, granted, this is ameliorated by the fact that being a strongly typed functional programming language, we can typically follow the types and things will generally work out. But as most of you probably are aware, just following the types isn't guaranteed to make sure that everything will work. Maybe unless you have a far more advanced type system than F# or Haskell or anything like that. So this is something that is sort of an intractable problem, I think. There may be some very advanced functional programming debuggability constructs that could be created and sort of generate this facade of how things are viewed by the debugger and try to present that in a useful way, but it'd be very, very difficult, and frankly, I have plenty of other problems to deal with. So another one is incomplete expressions really, really bust things up. So if you can see at the bottom there, I have a double ampersand because this is a big Boolean thing, but I actually put a type check error in there because that list.map ID call does not match the rest of the Boolean expressions that I'm checking. But you don't see a little red squiggle underneath it. You only see the one at the bottom, and that's because the compiler actually recognized this as an expression during parsing and said, hey, this thing is not complete, so I'm just going to give up. So we kind of have a tricky situation where we say, okay, well, we can know based on tools, we could go in after the fact and put an error in there and say that there's a type check error. But if you run this at the command line, you're not going to see that error. So this is kind of a usability problem now of, okay, do we show more errors than what you would get if you were to run this at the command line? We decided no, but maybe that's not the correct decision. I don't really know if there's a correct approach there. And now that I think about it, it might be a useful thing to to put an option behind and maybe say, hey, I want my editor to explode when I do something wrong, even if at the command line it's only one problem. Type inference is also very tricky. It works great for some types and product types and function values. I generally never have any problems with that from a tooling vendor standpoint. But if I'm trying to analyze something that depends on a type or expression that has errors or that is ill-defined or is incomplete, it's pretty much impossible for me to do that. Like could maybe go in and put holes everywhere and then try to go in through multiple passes and try to figure out what they should be or something. But that gets really difficult, and that starts, I mean, type inference algorithms are already expensive as is computationally, and so doing that many times can start to incur a performance penalty on someone, and so maybe that's not the best move either. And F#, because it lives on .NET, which has object-oriented stuff underneath it with inheritance hierarchies and overloads, can definitely struggle with some of those things. I believe in C#, F# does not do this, but I believe overload resolution in C# in some cases is reducible to the 3-stat problem. So we are sitting on top of that, and you can imagine that type inference on top of that sort of thing is kind of difficult. And here's an example. So I have 2 arrays. One is an array of strings. The other is an array of arrays. One thing that's fun about strings and arrays is they both have a similar property called length. Length takes a unit and produces an int. So in the third line of code there, I am deciding I'm going to map strings, map the length onto the strings, and I'll get some lengths. But when the compiler reads it, it goes left to right, and it says, okay, I'm doing array.map, sweet. All right, I got a Lambda function. This is pretty cool. X.length. Well, I have no idea what X is. So I'm just going to say, bleh, this thing is just broken. Which, if you look at it, that kind of seems weird because strs is string, so it should be able to resolve it, right? Well, actually, that can get rather complicated. This is a trivial example, but this sort of says, okay, well, here's a member, could be an overloaded member. I'm going to now need to sort of back out and say, okay, can I search for all possible other members that sort of make sense and try to make sense out of this thing that I got here and maybe try to unify that with the thing that comes afterwards. Well, stepping out and searching the entire space can imply a massive number of overloads and a large inheritance hierarchy. That's not really something that we like to do in the compiler because that could have you write code that could basically explode your compile times, and we're not really fans of that, so it emits an error. However, the tooltip shows that X is a string. So clearly something knows that a string is there, and that something is the tools, because tools have to be error tolerant, remember? So we have to understand that, hey, there was a type check error, but we still want to try to process stuff. And it just so happens that we were able to process it such that we knew that X was a string. So it's kind of confusing, isn't it? That the tools are able to show you more information than what the compiler could give you. But I'm going to put forward that this is a lot better than the inverse, where the tool's showing you less than what the compiler does. So imagine if this was a type check error, but we didn't show you the red squiggle. That'd probably make you mad. So we don't like doing that. Typically, these sorts of things are made better by using explicit like piping things into things. So in this case, you have the strs, and we're piping that into array.map. And in that case, the type checker knows that strs is an array of strings, and when we're calling array.map, it knows that X inside the Lambda function is a string, and hurrah. But these are things that we can't really avoid in tools. We have to like live with these realities, and maybe we'd be able to offer a few little fixers that could identify common patterns and transform like that third line into the fourth line. But identifying all possible like tricky patterns like that gets really complex. So there's sort of three fundamental usability questions here, which is, do we sort of have the tooling be, I don't know, like isomorphic to the compiler? And it's sort of weird talking about it in those terms because the tooling is the compiler, but is there sort of like a view of the compiler that we want to be equivalent, or do we want to show less information, or do we want to show more information? It's, I don't really have a good answer to any of these other than at a case-by-case basis, you try to do the best, and maybe if it's configurable, people can tune it into the opposite behavior if that's what they would prefer. I view this as just sort of a fundamental problem with programming language tooling that might not really be solvable. Another fun quirk is performance, which everybody really cares about. So having a compiler, when I said living as a long-running server process, that implies that similar performance problems that you would have with a server process are also happening here. Allocations over time, which compilers love to allocate, they really, really kill long-running server processes. And when you're spending more and more time in the GC just cleaning up a bunch of garbage, that's time that you could have been spent doing useful things, like something else in that process. Maybe you could have had multiple server processes doing things, but instead it's GC pause times are also, well, they're typically not that bad if it's for like very small amounts of data. It's just sort of like noise that nobody ever notices. But if you allocate very large objects, especially in .NET, they get allocated on what's called the large object heap. Those, when they're collected, have to pause all threads. It's just the system that you're living on. And so when you get that, you get a UI delay. And nobody loves typing something in an editor only to have the editor just pause, and they get no feedback at all on what they did, and then the characters just kind of swoop in afterwards. It's a horrible experience. So you might say, okay, well, I'm just going to cache all the information. Well, that's not really going to work, because if you hold that data strongly, you're going to have a memory leak. And if you decide you're going to hold the data weakly, then the garbage collector is going to go in and clear it out for you. And so you're going to get cache misses, and you're going to have to recompute stuff. So you just can't really allocate a whole lot. And that's kind of a problem, especially for functional languages, because at least in my observation of Scala, Haskell, and F#, they love to allocate a lot, because once you have a lot of big things, you can play around with them and keep them in memory. But that sort of doesn't really work out to your favor if you're trying to host yourself as a server process. And so .NET has this concept of value types. So there's reference types, things that are allocated on the heap and then tracked by the garbage collector and cleaned out. And then there's these things called value types, which are just cleared out based on scope. If you just want to make everything a value type, that's not guaranteed to actually fix your problem. If you have a very small amount of data, that can usually work out. But if you have larger data, or depending on the patterns in which you use that data, you end up copying it all the time, and you end up spending a whole bunch of CPU time doing copying of values rather than cleaning up stuff inside of a heap somewhere. And so there's really no winning aside from just do better, just make code run better, I guess. What that actually implies is really thinking about a different architecture and thinking about how tooling patterns affects compilation. And that also, in turn, affects how you do language design. And you want to design things such that you can represent them in the compiler in a way that doesn't totally destroy performance or doesn't destroy usability, that sort of stuff. So, if you want to do programming language tooling, it's a lot of fun, but I'm going to warn you, it's a lot of work. So if you take this approach, then the compiler needs to understand tools as first class, period. You can't have a compiler that is just sort of ignorant of the fact that tools are going on there and decide to tool on top of that, because you're only going to get a very small amount of features, and you're probably only going to work with very small amounts of code. That API also requires maintenance, and the instant you open it up, people will take a dependency on it. And if you decide you're going to break that API, you're going to hear about it. I speak from experience here. Performance really, really matters. You're going to be thinking about it all the time. That's just how it's going to work. Oh, well, I mean, you won't have to. I guess I should say this presupposes that you want your users to be happy. If you're uninterested in that, then sure, performance doesn't really matter. But honestly, users have a lot of high expectations. And so if you want to get people into functional programming, they come from C# or Java, they have immaculate tooling. And it's very difficult for somebody to give up that quality of tooling and use significantly worse tooling just to work in a language that they're not very acclimated to yet. So there are some alternatives here. You could have a totally separate tooling compiler or presentation compiler, which some languages choose to do. That's twice the work, so I don't recommend doing that. That also means that core language development is going to happen in the non-tooling compiler, and core language development is not going to usually care about what happens in the tooling compiler. So the tooling compiler is always going to be playing catch up, and it's just going to be a lot of not fun. So another alternative is you could decouple some of the data that a compiler produces and consume it with other tools. This is very similar to the way that I believe Scala's Semantic DB is doing things, and the Metals project that sits on top of it. This is the better alternative, but I think it's still a suboptimal, because it still relies on a non-tooling aware compiler to generate information. And when you have a very large project that you're changing all the time, you need to be constantly generating that information. And so if the core thing that is throwing stuff at the database is slow or difficult, then you're going to be just inheriting those problems. On top of that, you do need to have a bit of an ad hoc implementation of a compiler, or pieces of a compiler, rather, sitting on top of the semantic information, because it's unlikely that the information that's sort of decoupled there is going to map directly to an editor host, right? Like if you want to have, a completion list, so a set of symbols and some information about those symbols, what you display in an editor is not going to be isomorphic to the stuff that's inside that database that you're extracting info out of. So you need a way to convert that. Additionally, I didn't cover this, but project and integration tooling is about an equal amount of work to language service tooling and compiler development. Uh, Performance matters even more here because it's all about management of resources, and there's not really any flashy features. There's just a whole lot of it just works features. And so if it just works is false, nobody's very happy. And if you get something working, people usually just sort of say, "Oh, cool, that's how it should be," rather than thanking you for building this really cool, flashy thing. And impedance mismatch are absolutely this is absolutely going to happen because a given host, especially something like Visual Studio, which has been around since the late 1990s, is going to have a way of working that is not going to jive with a functional language. That's just going to be the case. Debugging is also a lot more than just breakpoint resolution. First of all, you need to have a good debugger. That's also a very difficult thing to do. And a given language is going to have constructs that might be considered undebuggable. And that's really frustrating for people, especially if something is wrong and they can set a breakpoint, but then or maybe they can't, and then they go, okay, well, I want to see what's going on here, and so then maybe they have to rewrite their code a little bit just so it can be debugged, and that's really nothing that anybody likes to do. So maybe the solution for that is just everybody needs to be really, really smart and never write bugs in their code, but unfortunately, that's not the way that the world works. Now, I don't want to scare you off, though, because it is a whole lot of fun. So if you are interested at all in programming language tooling, or if you're already doing it, I would absolutely love to talk to you. I'd love to learn about some approaches you may have thought of or that you may have tried. And I recommend getting into it because even though I don't know, if you're a glutton for punishment like me, it's a lot of fun. But even if you're not, it's also a lot of fun because you get to play with syntax trees all the time. And who doesn't like doing that? So thank you very much.